In this lesson, we're going to talk about properties of parallelograms. And we're first going to define a parallelogram. A parallelogram is a quadrilateral, that's a four-sided polygon, having two pairs of opposite parallel sides. So the standard diagram for a parallelogram looks like this, and we can mark the parallel sides. Okay, those are supposed to be arrows there. No, they don't look so good, but there's our diagram for a parallelogram. Using that definition and our knowledge of triangle congruence, we can prove other properties of parallelograms. And these are some of the standard ones. Opposite sides are going to be congruent. Opposite angles are going to be congruent. So diagonals are going to bisect each other. So the diagonal of a parallelogram, the diagonals are going to look like that. They bisect each other, and one pair of opposite sides are parallel and congruent. So we're going to prove a couple of these in our notes, and then in class we're going to prove a few more. So here's our proof. We want to prove this sentence. If a quadrilateral is a parallelogram, then its opposite sides and angles are equal in measure. And we're going to do that. These parallelogram proofs are typical, where you're not given a diagram or anything, you're just given a statement. So you have to draw your diagram. And incidentally, this is how you label any kind of polygon. You start in one corner and you go around. So A, B, C, D. You don't go back and forth. You don't say A, B, C, D. You have to go around. Now, it really doesn't matter the orientation. You can go counterclockwise like we're used to, or clockwise. In the end, it'll work out, but it's very important that you go around and not back and forth. So we want to prove that its opposite sides and angles are equal in measure. So, for instance, we want to prove that AD is congruent to BC, and AB is congruent to DC. Then we also want to prove angle A is congruent to angle C, and angle D is congruent to angle B. Now that looks like an awful lot of stuff to prove, but in fact, if I can get congruent triangles, I can prove all of this in one statement, and that statement would be corresponding parts of congruent triangles are congruent. So I want to create, actually it might have to be two things. I might have to do two sets of triangles to do this. So I'm going to start off with one diagonal. If I can get the top triangle and the bottom triangle congruent, I can use CPCTC to get all these parts congruent with the exception of angle A and angle C. But I could do that too if I break it up in parts and get opposite angles congruent. So let's do this. Let's write down our given. Our given is easy. It's just parallelogram ABCD. So I know it's parallelogram, which means I'm going to use the fact that opposite sides are parallel. That's the definition of a parallelogram. And then we'll prove all these other facts. So there's given. Okay. Knowing that, I know that opposite sides are going to be parallel. So I'm going to say DC is parallel to AB, and I'm going to say that AD is parallel to BC. That's by definition of a parallelogram. Or you could say in a parallelogram, opposite sides are parallel. Okay. Once I have that, I'm going to start proving the triangles congruent. I can get AC is congruent to AC. That's our reflexive property. Okay, so I have that. And if I can get some angles congruent, I could use angle side angle. So I know from parallel lines that those two angles are alternate interior, and these two angles are alternate interior. So I'm going to do this in one step. I'm going to say angle CAB is congruent to angle ACD, and the other one's DAC, angle DAC, is congruent to angle BCA. Okay, because if parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, so I have those angles congruent, and I'm going to go back and now say that the triangles are congruent because I have angle side angle. So I have triangle ADC is congruent with triangle CBA. And that reason is angle side angle. That's enough to get almost everything congruent except the last pair of angles. So I can now say that AD is congruent to CB, and AB is congruent to CD, and I can also say angle D is congruent to angle B. That's because corresponding parts of congruent triangles are congruent. Now we have to work on getting angle A congruent to angle C. We can do that either by getting the other triangle, drawing the other diagonal, or using the partition postulate because we already have congruent parts. And if I add them together, I can get the wholes congruent. So I'm going to finish this up in two steps. I'm going to say that angle DAB is equal to angle DAC plus angle CAB. And I'm also going to say angle DCB is equal to angle DCA plus angle BCA. That's the partition postulate. The whole is equal to the sum of its parts. Okay. Finally, by transitive, I can now say that angle DAB is congruent to angle BCD. And that's the transitive property, because if two things are equal to the same thing, they're equal to each other. And we have all those congruent pieces that we add together, so it makes the whole congruent. So that's how you prove all the other properties of a parallelogram. Now that we have those properties, we can use them in other proofs where we start with parallelograms, or if we're trying to prove that parallelograms, a quadrilateral is a parallelogram, we can use any of these properties. Alright, so now we're going to prove another property of a parallelogram. If a quadrilateral is a parallelogram, then the diagonals will bisect each other. Here's my diagram, ABCD, and this time I drew diagonals and I labeled the center E. So I'm going to prove that AE is congruent to CE and DE is congruent to BE. And that by definition, that means that they bisect each other. So I start off with my given. I'm only given that it's a parallelogram, but I can use the properties that I just proved before. So if you look at this, if I need to get these parts congruent, that means I need to use CPCTC, which means I need to get two triangles congruent. So let's just work on the top and bottom. If I can get these two triangles congruent, that's enough to get the corresponding parts congruent. Well, here's what I know. I know that opposite sides of a parallelogram are parallel and congruent. So we can say that AB is congruent to CD, and we can also say that AB is parallel to CD. That's because opposite sides of a parallelogram are congruent and parallel. So they're congruent and they're parallel. That means I can get angles because these are alternate interior And these are alternate interior. So I can get angle, side, angle. That's not the only thing you could get. You could get angle, angle, side as well. But I'm going to stick with angle, side, angle. So I can say that angle EAB is congruent with angle ECD. And at the same time, I can say angle EBA is congruent to angle EDC. And that's because if parallel lines are cut by a transversal, then alternate interior angles are congruent. So we are just a few steps away from finishing up this proof. This is a much shorter proof here. Now I have enough to say that triangle AEB is congruent to triangle CED because I have angle, side, angle. Angle, side, angle is congruent with angle, side, angle. That's enough for my final statement. My final statement is the fact that AE is congruent to CE and DE is congruent to BE. Corresponding parts of congruent triangles are congruent. So there's a couple of proofs to start off this looking at parallelograms, and we will practice more of these in class.